what's g of 1 on the graph?
Altogether that would be 5, I believe.
Well, let's see. That would be g of 2. That would be g of 0. G of 1 looks to be almost
Wait, was it
0.
-2?
Negative 2, perhaps. Let's see. 3 minus 8 plus 5. No, it's 0. In other
It's
words,
0?
yeah, there's 1 on the horizontal graph. I don't know if you can see this cursor or not. It turns into, I can barely see it there. But can you see that? Let's do this.
Okay.
That's much better.
Yeah.
Now, if we go to g of 1, it's about right there. It looks to be 0.
Okay.
And if you plug it in, you get 0. Because 1 minus 8, oh no, 1 minus 8 is minus 7 plus 5 is minus 2. So actually it looks to be somewhere about there.
Okay.
And g of 8, approximately, what is it?
I got 5.
Well, look on the graph. What is g of
So
8?
G of 8.
What does it look to be?
It looks like it's by 0.
It's about 0. And you got 5 by algebraically solving for it. In other words, 8
Yes.
cubed minus 8 times 8 squared, well, that's 0, plus 5. So it actually looks to be about right there, above the x-axis. All right.
Okay.
Use the graph to find domain and range. On number 9, what is the domain?
So that's the x coordinate, right?
Yes, it's the allowable x-coordinates. So from that graph, what do they appear to be?
Negative, infinity, and infinity.
Yeah, in other words, all real numbers. I don't see anything on this graph that I wouldn't be able to make x. In other words, even 0, I can let x be 0. It seems to have a value. What's the range?
-1. It looks like -2 and infinity.
That looks like positive 2 to me.
That's 2. Oh yeah, +2.
Yeah,
Yeah, you're right.
that's 0.
Yeah.
That's 1, that's 2. So the range is, 2, which it appears to be able to be, to infinity.
Okay.
Do you use interval notation?
What is that? Yeah, that's what it looks like.
Or,
And then sometimes you have to make a box.
well, okay, sometimes they use interval notation like this. In other words, it'd be minus infinity to 2 in combination, in union, with 2 to infinity. So
No,
interval
okay.
notation allows you to do multiple intervals if your answer is in multiple intervals.
Okay.
But there's lots of ways to state range. You could also state range, y is greater than or equal to 2. That's also an answer. Number 10, what's the domain look like?
It looks like 1, 2. Like it looks partially a little bit over 2. Or -2.
Well, if that were true, there would be a vertical asymptote there, right? In other words,
Yeah.
you're saying that maybe there's a vertical asymptote at y equal, or at x equal -3. That would be -1, -2, -3. And it does look like there could be a vertical asymptote there. But when we see the arrow on the end of the line, if they don't draw a vertical asymptote, it's not there.
It's called arrow.
The domain is all real numbers.
Okay.
Okay? Because otherwise they would have had to draw it like this. They would have had to put a vertical asymptote there, and then probably another vertical asymptote there. And what did this thing look like? It was just a big giant W. In other words, it looks like it could be that kind of function. But if it was, they would have had to put the vertical asymptotes in there. And you could even still put an arrow on it, because all that arrow means is it goes to infinity in the vertical direction.
Okay.
But as far as going to infinity in this direction here, if there's no vertical asymptote, then it goes to infinity in that direction. As an example, let's look at a more familiar function. This is y equal log of x. This is one of the flattest functions you will ever see. And by that, I mean you have to go 2 miles to the right on the x-axis to go up 12 inches vertically. Understand?
Okay.
I got to go 2 miles in that direction for this function to rise 12 inches.
Okay.
So it would be very, very easy to look at this function and think that there's a horizontal asymptote there. But in fact, there is not. In other words, as x goes to infinity, the domain is all reals. The domain is all positives. In other words, with this function here, x has to be greater than 0. We cannot take the log of 0. We can take the log of positive numbers only. So this function here, x can go from 0 to infinity, but the important part is what the range of this thing is. There is no horizontal asymptote. So the range is y is a member of all real. Can go from negative infinity, and it eventually goes to positive infinity. If you go far enough to the right, even though I got to go 2 miles for every 12 inches, there is no limit on y. If I plug in a big enough number for x, then y will just keep getting bigger. So that common function that we're used to is not all that different than this, in the sense that we can't really tell by looking at it whether there's vertical asymptotes, but since they have not drawn them and they put arrows there, there are not any. What's the range on number 10?
1, 2, 3. 3 and negative infinity.
Give it to me in whatever notation you use. Y or interval notation, whichever you like.
So I would do parenthesis 3, comma, or negative infinity, then the 3.
No, you got it. It doesn't go to negative infinity. If we're looking at range, we're only looking at the vertical range.
Okay.
Okay? So the vertical range on the low end is -3.
And then it goes to infinity.
Then it goes to infinity, but should this be a parentheses or a bracket?
A bracket.
Correct. Because it can be -3. Okay. By number 11, the domain.
I put, okay, domain. 1, 2, 3, 4. It starts off at -4. And it looks like it ends at 1, 2, 3, 4. And it ends at 4.
I think that's 5.
5.
1, 2, no, you're right. No matter how many times I looked at it, it looked like 5 to me. It's 4. And what do I need? Parentheses, brackets, what?
We have a bracket on the left and a parenthesis on the right.
Other way around.
Other way around.
This is the open circle, which means it cannot be -4. This is the closed circle. That means it can be +4.
So how come, can you help me distinguish the difference between the both and how to use them?
Yeah. If you were to reverse this, let's make this a solid dot and let's make this an open dot. Then it would be this.
So if it's a solid dot, it's a bracket.
Yeah.
And if it's open, it's a parenthesis.
Yes, that's the difference.
Okay.
What's the range on this?
The range, so the lowest point I see is -1, and the highest point I see 1, 2, 3, 4, 5, 6. The highest point is 6, I believe.
Okay, what goes around each of those?
Would there be a bracket since it's a negative?
Well, it's not because it's a negative, but because it does attain that value.
Okay.
On both. In other words, it does reach -1 right there. And it does reach +6 right there.
That's because it's not an arrow and it's actually on the graph, correct?
Yeah. In other words, it's not approaching it. As another example of a more familiar function, if I say y = 1/x, that is hyperbolic. Well, the domain on this is -infinity to 0, and it cannot be 0, in combination with 0 to +infinity. So this would be the domain. And I use parentheses because x can never be 0. I cannot divide by 0. And you have a vertical asymptote running right down there. Okay, where it approaches it on the bottom and it approaches it on the top, but it never hits it. You also have a horizontal asymptote right there because y can never be 0. There's no value you can think of for x that makes y 0. So it never goes through the horizontal asymptote or the vertical asymptote. And so I have parentheses in both cases. Or in all 4 cases, I should say.
Okay.
We seem to be missing a... Oh, there, 12 must be over here. No?
No, there isn't a 12, yeah.
There is no 12. I can see why they'd skip 13, but 12 I've never seen skipped.
Mm-hmm.
You know,
That's weird.
you know that most hotels do not have most hotels do not have a 13th floor?
Yeah, in New York, I noticed that.
Everywhere. Yeah.
Oh.
Well, I mean, I don't know if it's everywhere, but it's most places. You will not
I
find
do
it.
know in China they do have 13.
Probably
Because
in
they don't
China
see
they
it
do
as
because
there.
it's not necessarily considered an unlucky number in China. But in the
Yeah,
United States, people consider it an unlucky number enough that they don't like staying on the 13th floor of a hotel. So
yeah.
they don't put it on there. They skip it a lot of times. Maybe,
Very superstitious.
well, it's more having to do with business. In other
True.
words, if you had two identical hotels, one that had a 13th floor and one that didn't, people would be more likely to stay at the one that did not have a 13th floor. They wouldn't want to stay on,
Hmm.
most people are that superstitious that they wouldn't want to stay on the 13th floor. Okay, so number 13, what's the domain?
Domain. I see it starts off at 1, 2, 3, 4, -5,
Okay.
and it continues on to infinity.
Okay, so tell me in interval notation what it is.
Wouldn't I need a bracket on the left due to the solid dot?
Yes.
And then a parenthesis on the other side.
Parentheses always go around infinities, negative or positive. You never have a bracket on a infinity.
Okay.
What's the range on 13?
The range. The lowest point I see 1 to -2, and then the highest I see is 1, 2, 3, 4, 4. Oh, is that because the arrow?
Yes.
Okay.
Now what do I need around it?
I need parentheses.
Oh, brackets,
The
okay.
bracket on the left because that's actually there on the figure.
Exactly. You can have that value. Domain and
Okay.
range is all about what you can have. Can you find a y that's equal to -2? Yes, you can. Right there. Okay.
Okay.
Number 14. Domain.
14. My domain will be
Now this is when
1,
we
2,
kind of need interval notation here. The domain is actually in two different intervals. Notice that's an open dot.
Yes.
So it cannot be 1, 2, 3, 4, -5. Did I count? 1, 2, 3, 4,
3,
5.
4, 5.
So it can't be -5. So how am I going to write the domain on this thing?
Would it be negative infinity?
2.
Um,
I can't say to
1,
this number because I'm not allowed to have it be -5 according to this picture. So I got to go up to -5 with a parentheses in combination with what?
oh, then I would have to use the circle. So then,
Well, not yet. In other words, we're still at this point right here. Is all we've done is we've gone from negative infinity to -5 with this part here.
okay.
Where's the rest of it start?
On the right, I see 2 dots.
Well, let's start where we left off. -5.
Okay.
To what?
Then 1, 2, 3.
Bracket.
Since it's actually there.
Yep. We can have 3. We can't have -5. And the fact that that's a closed dot doesn't affect our domain much. Well, it does. If it was an open dot, we would need another interval. But in other words, we can have all values for x that are in that interval. And that's exactly what the chart shows. We can't go to the right of 3. We can go all the way to negative infinity, and we can do any number in between those except minus 5.
Okay.
What's the range?
The range is, so it starts off at, wait, there's 2.
Okay.
So I'm going to have to do the same thing I did before.
No?
Oh, I wouldn't?
What's the low end of the range?
1, 2, 3, 4, 5. Negative 5.
Bracket or parentheses?
Bracket.
Because of this one, it's at the same point as this one, but we can actually attain minus 5 for y.
And blue. Okay.
To what?
To, I see an arrow on the left, so infinity.
There's your range. So we don't
Okay.
break that up into 2 intervals.
Okay. Okay, 16.
Number 16. What's the y-intercept?
Y-intercept.
Yeah. What is going on right here? Is that an open dot? Is that a closed dot? Is that a vertical asymptote?
It's a closed dot at the point.
Yeah. In other words, if we look at the function, we're fine with having x be equal to 1, right?
Yes.
I can take the square root of 0. So there's nothing that prevents x being equal to 1. What is f of x when x is equal to 1? Is 0. So that's actually a closed dot, even though they don't draw it as such. I find it a little interesting that they don't draw it as such, given the fact that they put closed dots on all these other curves. I would have expected them to put a closed dot right there. But regardless, what is the domain? This time, given in terms of x, what does x have to be?
Starts off at 1.
So x has to be greater than 1 or greater than or equal to 1?
Greater than or equal to 1.
Okay, and that defines the domain. In other words, all we're doing is we're defining what values of x am I allowed to put in there.
Okay.
What's the range?
The range will be
y
0.
Y what?
Equal to 0 or more.
Greater than or equal to 0.
Okay.
This arrow, I guess this arrow must mean that it goes in both directions to infinity. It goes not only along the horizontal axis to infinity, but it goes vertically to infinity also. If I did have a horizontal asymptote, it would probably be drawn in there. I kind of find it interesting that none of these curves, do they have any vertical or horizontal asymptotes? And so we don't know how they draw those. 17. What can x be?
So my domain. So that would be -1 and.
Hold it. We're looking
Yes.
at x. What can x be?
Oh, so should I factor?
Not yet. You don't need to. Another way to do these, there's two ways to do these. You can look at the curve and figure out what the domain is and the range. Or you can look at the function if you look at that function, are there any values of x that give us problems?
Yes, x cubed and x squared.
Why does that give us problems?
Because it's not at the simplified form, or we're just trying to find x.
Doesn't matter. Can I have x equal to 0?
Yes.
Can I have it equal to minus a billion?
Yes.
Just looking at the function. And
Yes.
can I have it equal to plus a trillion?
Yes.
So there's nothing that x cannot be.
Correct.
So my domain is all real numbers.
Okay.
Finally, what's the range on that 17?
Then the range is the same thing, all real numbers.
Yes.
So that's all I had to do?
Uh-huh. So
okay.
What this kind of is it's not a complete illustration, but it shows that you can almost figure out domain and range from the graph. I say almost because some of these it's tough to tell whether we're looking at a vertical asymptote here. And if we are, then it completely changes the domain. But they don't draw it as such, and they put an arrow on there, so I'm assuming there are no asymptotes in either of these curves. Any of them, in fact.
Okay.
You only have a half hour today, right?
Yes.
Okay, I was just looking at any.
Thank you.
I don't see any of the problems having asymptotes anywhere.
Oh, okay.
Okay. So at this point, you're not having to deal with asymptotes.
Okay.
Okay. All right, Taylor. Let's see. You got another session tomorrow at 6:30, my time.
Yep.
Talk to you then.
Okay, sounds good. Talk to you then. Bye.
Bye-bye.